Got it. Okay, so today is June. Wow, cool. June 2. Our object today is really going to be solving right triangles with trigonometry. So before we start, let's take a look at a couple of triangles, okay? We'll look at two different triangles. They've got to be right triangles, so I'm just going to draw one right triangle here. I draw another one right below it, okay? Okay. Always start with the angle. Let me highlight that. Always start with the angle, okay? So the way I like to teach this, you guys paying attention? The way I like to teach this is this. Just imagine that this is a lake. This is a triangular lake. It's a perfect, somebody built this lake. It's a triangular lake, right? And Arlo, you're standing right here. That's you, okay? That's you. So if Arlo's standing there and I say, Arlo, throw a rock to the opposite side of the lake, it'd be right there. Everybody agree? So he's standing here. I say, Arlo, throw a rock as hard as you can to the opposite side of the lake. That'd be the opposite side of the lake, right? Everybody agree with that? We already know the name of this side. What's the name of this side of the triangle? Hypotenuse, right? And so this side is right next to him. He's standing right here. That's my adjacent side. Okay? Great. Now, Arlo decides to walk around the lake. And now he's here. And then I say, okay, Arlo, throw a rock to the opposite side of the lake. So the opposite side of the lake this time is this side, correct? The hypotenuse is still the hypotenuse. That's not going to change because that's always the longest side is the hypotenuse. And then Arlo's standing here, so this is my adjacent side. These words, opposite, adjacent, and hypotenuse, are the same words that we see up here. Right? But everything depends on the angle. You've got to go to the angle first because you don't get these names unless you go to the angle. Put your phone away. Okay? So you've got to go to the angle first and say, I'm right here. That's my opposite side. No. I walked around the lake. I'm right here. That's the opposite side. Does that make sense? So you start with the angle, and then you label the names, okay? So you start with the angle, and then label the sides, okay? So you start with the angle, then label sides, okay? Now, as I was showing you before, it's true on all of these, that as you change one thing in a triangle, everything else changes with it, okay, right? So as I change the angle in a triangle, you guys watching? So I change the angle of the triangle, the other side's changed with it, right? So it's a ratio. It's a ratio between one and the other. Now, if we have three different ratios, the sine, S-I-N, E, it's called sine, but its abbreviation is S-I-N. And that's, I see that on my calculator, S-I-N, sine. But it's not sin. Sin's for church. It's sine, okay? So sine of an angle is a ratio. It's a ratio of the opposite side over the hypotenuse. Okay? Cosine. Cosine is a ratio. Its abbreviation is just plain old cos, but it means cosine. And again, it's in your calculator right there. So cosine is that button in your calculator. Okay? It's a ratio of the adjacent side over the hypotenuse. And the tangent, but we abbreviate it as tan, and it's on our calculator right there. Our tangent of theta, theta is the angle, is equal to the opposite side over the adjacent side. How am I doing? So far, so okay? Am I making sense? Well, let's go ahead and try and figure out some of this, okay? So in the first example, I have a triangle. It's a right triangle. I have sides of 3, 4, and 5, okay? So this is write each of the trig ratios. Well, these are my ratios. These are my ratios. These are my ratios. From angle A and angle B. Okay, so first, we're going to do, so it's two questions. There's two questions here. One is going to be angle A, and then the other is going to be angle B. Okay, there's two questions. So I want the trig ratios. That means I want the sine of A equals. I want the cosine of A equals. I want the tangent of A equals. Okay, I'll let you catch up. It says I want the ratios from A and B. And the ratios are the sine, the cosine, and the tangent. Those are the trig ratios. Okay. I also need to do angle B, so I'm going to need the sine of angle B equals something, cosine of angle B equals something, and the tangent of angle B equals something. Okay. All right. Now I haven't done the answer yet, but I'm just setting up my questions. Okay. So my question says, write each of the trig ratios from A and B. So I set up sine, cosine, and tangent of A, sine, cosine, and tangent of B. How am I doing? Give me thumbs up. Or sideways thumb, okay, or down thumbs, okay? So let's see if we can do this, okay? So let's go to angle A, okay? So if we go to angle A, there's angle A. So always go to your angle first. Always go to your angle first. Always go, start with the angle. Always start with the angle, okay? Now label the sides. So here you are. Let's just imagine you're standing here, okay? Just hypothetically go with me. You're standing here, this lake, so that means that the 4 would be my opposite side. Does that make sense? My 5 has to be the hypotenuse. Hypotenuse is always the longest side, up to the 90. And the 3 is the adjacent side, okay? Everybody okay with that? Now give me thumbs up. Okay, do the name of the sides make sense? Thanks, Selena. That helps, right? Good. Now, all right, sine. Look up on the board in blue. What's the sine ratio? What's it say? Look up on in blue. So the opposite is the 4 and the hypotenuse is a 5. Answer. There it is. That's my ratio. Ratio is just a fancy word for fraction. Cosine of A. Well, look up on the board. What's cosine say? Which is the 3 over the 5, right? Tangent. Tangent of A. Look up on the board. What's tangent? Which would be my 4 over my 3. Okay, so far so good? Give me thumbs up. Good. Now, let's go to the other side of the lake. Okay, so now we're going to go over to angle B. We're going to walk over to angle B. So I'm not at A anymore. I'll go over to angle B. I'm over to angle B. And when I'm at angle B, all of a sudden, my names change, don't they? Don't my names change? I'm at B. So that's not my adjacent side. I'm going to throw the rock to the opposite side. That's my opposite side. And change that. This is not the adjacent side or opposite side anymore. This is my adjacent side. And my hypotenuse does not change. Okay? So if I'm at angle B, my opposite is the 3, right? And my adjacent is 4. Okay? Now, I want you to try and do sine of B, cosine of B, and tangent of B. I want you to try it. The ratios are on the board, right? I want you to try it. Okay, Scott?
So, do we never find this for C because what if the
Correct.
hypotenuse also
Amazing question. Thank you. Really good question. Okay, we measured that tree here. I'm going to answer your question this way. It's an easy way to answer. We measured that tree, right?
Yeah.
What if we would try to take that kind of measurement there? It's impossible, isn't it? What if you stand right underneath the tree and your angle, you take the angle which is 90, you never use the 90. Never,
because
ever.
It's already there.
It's already there. So never, ever, ever use the 90, okay? Good question. Okay, so guys, take a minute to answer these, okay? Take a minute. Bring angle B. It looks like Peyton's already got it. Good job, Peyton. So sine of B, what'd you guys get for an answer? Sine of B? 3 over 5. There it is. Opposite of hypotenuse, 3 over 5. Cosine of B, what'd you get?
4 over 5.
4 over 5. Good. Tangent of B?
3 over 4.
3 over 4. Thumbs up. Thumbs up. Everybody get that? I want to see it. Okay. Selena? Axel? Good? Okay. All right. Turn the page. So far, so good, right? Now, we can use this information to solve a triangle, okay? So to solve a triangle, let's write a few notes, okay, on the side, okay? When I solve a triangle, first thing I always do is 1. Start at the what? Start at the what? Always at the angle. 2. Label your sides. Okay, let's see what I've got. So if I start the angle, 36, right? I know 36 degrees. Don't start at B. Don't start at B because I don't know what B is, right? B is like, well, I could figure out what B is. But start your angle, okay? Label your sides. So that means BC has to be my opposite side. Everybody agree with that? Throw the rock to the opposite side. My 12 is my adjacent side, right? Everybody agree with that? And the hypotenuse, I don't know what the hypotenuse is, but there it is, okay? 3. Use the given side. What's my given side? What side do I know? What side do I know? Yeah, I know the adjacent. That's 12. Everybody agree with that? I know the 12. And then, what do I want to solve for? Use a given side, and then identify, and then 4, identify the side to find. Okay, what side do I need to find? Well, let's look at the question. Find the length of BC. So I need to find the opposite, don't I? Identify the side to find. I need to find the length of BC, so I need to find the opposite, okay? Now, 5. Use the correct trig ratio. All right, what does that mean? Well, am I going to use that one? Yes or no?
No.
Why not?
Because we're not looking for the sine.
We don't care about the hypotenuse. We don't know the hypotenuse. I agree. Are we going to use that one?
No,
Why not?
because we don't have the hypotenuse.
We don't care about the hypotenuse. You guys agree with that? We're going to use that one?
Yeah.
Yes, because we want to find the opposite and we know the adjacent. Thumbs up on that? So we got three choices. We want that one because we know we want to find the opposite of the adjacent. Awesome. Does it seem like it's not too bad? So let's write it down. So what I want is the tangent. So I'm going to write tangent theta equals my opposite over my adjacent. Okay, how am I doing? Theta is a fancy symbol for angle, isn't it? Theta means angle. So I'm not going to write theta. I'm going to write 36 degrees. So I'm going to go tangent 36 degrees equals my opposite, which I don't know what my opposite is. You want to call it x? You want to call it BC? What do you want to call it? X it is. Over my adjacent, what's my adjacent? 12. Good. Okay, now I can solve this. I can solve this pretty easily because if I'm going to solve for x, it's x divided by 12. What's the opposite? How do I solve for that?
Multiply by 12.
Yeah, multiply by 12, so multiply both sides by 12. Multiply by 12, and so I can get this answer. I almost got it. So in my calculator, I'm just going to go 12 times the tangent of 36, and I'm going to get my answer. So I'm just going to use my calculator. Okay, what is 12 times the tangent of 36? 8.72. 8.72 centimeters. What do you think? Pretty easy? It's not that bad. Okay, I've got two more examples. Okay, example 2. Find length of GP. GP. Okay, right here. Let's call. You want to call it X? Should we just call it X? GP. Okay.
That's I.
Now, step 1. Oh, GP. Thank you. Thanks, Ava. Okay, step 1. What's our step 1? Step 1. Okay, right there, right? Step 2. Okay, so the 15 is my opposite. You guys agree with that? My x is my adjacent. I don't care about the hypotenuse. I almost did, but I can't. I did it wrong. Okay, so, all right, which am I going to use? Opposite, adjacent. Look up there. Which one am I going to use? Sine, cosine, tangent. Sine, cosine, tangent. Opposite, adjacent. Which one am I going to use? Sine. Okay. Okay. Let's take a look at it. I've got. I know the opposite. I want to find the adjacent. Which one? Opposite, adjacent. Which one? Opposite, adjacent. It's got to be tangent. You guys agree? It's got to be tangent. We will do tangent today for all of our problems. Tomorrow we'll look at the other two, but it's definitely tangent. So I'm going to rewrite tangent of theta equals my opposite over my adjacent. Okay, right? And then theta is just a fancy symbol for angle, so I'll put my 42 degrees in for my angle. So I'll go tangent of 42 degrees equals my opposite side, which is the 15, right? Over the adjacent side, which is the x. All right? How am I doing? Now, if I multiply by x, it doesn't really solve for x yet, right? Multiply by x, I'll get a x times the tangent of 42 equals 15. I'll stop for a second, let you think about what I did. I got to solve for x, so I multiply by x and it brings it up here. Tangent of 42 is just a number. Tangent of 42 is just a number. It is just a number. So I'm going to divide by tangent of 42, and I'll get my answer by using my calculator, right? So now calculator.
Would it be easier to divide by 15?
No, we're just going to do it exactly like this. And it's a little tricky on your phone, but on these calculators, you're just going to go 15 divided by tan 42. You're just going to do that. Super easy. Just like that. Enter. 16.66.
calculator knows what
Right, within this calculator is a special program that has got all of the different combinations of any particular angle you can possibly do, okay? It's an algorithm in your calculator. It's, as the angle changes, so do the sides. Does that make sense, Scott? And the calculator can do...
So it knows that if it's 42 degrees and 15 centimeters on the opposite side, then it knows.
Yes. Isn't that crazy? Yeah.
That is pretty cool.
Yeah, it's amazing. Okay, last one. A 5-foot boy. Here we go. This is Axel. But Axel's taller than a 5-foot boy, and he's a young man. But sits on top of a tree. Here it is. Here's my tree. This is exactly the problem we just did. Here's Axel again. Okay. He sights the top of a tree at an angle of 54 degrees. He's 75 feet from the tree. How tall is the tree? Okay. We're going to assume a right angle. So let's take a look at this. Well, step one. What's step one always? Step one. What is?
At the angle,
Start at the angle. Okay, so start at the angle. Good. Step two. What's step two?
regular side.
Yeah, so opposite is my tree. Adjacent is my 75. And the hypotenuse we don't care about, right? We don't care about the hypotenuse. It's not important in this problem, okay? So then, opposite adjacent, which trig ratio are we going to use? Look above in blue. Are we going to use sine, cosine, or tangent? Opposite adjacent. Everybody agree we're going to use tangent?
Yeah.
So we're going to go tangent. Theta equals the opposite over the adjacent, right? And then what? Well, theta is the angle. So instead of writing theta, I'm going to write my angle. So I'm going to go tangent of 54 degrees, right? Because my theta means angle, and my angle is 54, equals the opposite side, which is my tree, over 75, okay? How would I solve for t? Bam, 75. Multiply that by 75. Use my calculator, right? Let the calculator do the work. 75 times the tangent of 54. 103.2. That's my calculator. Says 103.2. So the tree.
But then you add my.
Yes, Scott, you're right. 103.2. And then you got to look here. Scott's right, because this triangle that we took is really suspended by that 5 feet. So we're going to add in the 5 feet. I hope that makes sense to everybody. Get 108.2 feet. What do you think? Can you do this? Okay, homework for today is going to be out of your journal. I've got page 298. I want 1 through 10 all. We want to get this done in here because you can use my calculators in here. If 8th graders, if you guys don't have a nice, good scientific calculator, you probably should get one, because you guys are probably going to be the ones that are going to take advanced math. You guys agree with that? If you don't have a good calculator, you can tell your parents Mr. Davies says you need one.
Steal my dad's.
There, yeah, but your dad's got an HP.